A Harvard astrophysicist believes there's a strong likelihood this is a craft of alien origin. They said it passed us safely. They said it was gone. But now, fresh calculations from Harvard suggest 3I-ATLAS may not have left us behind at all. Its true course remains shrouded in uncertainty, close enough that NASA is watching its every move. If the numbers are right, the object could be drifting back onto a path that brushes dangerously near Earth, or worse, the professor who broke every rule in science. Academia has always been a place where careers get made and destroyed based on what you're willing to say out loud. Most professors learn early to stick with safe ideas that won't upset their colleagues or threaten their funding. But Avi Loeb just threw that playbook out the window in the most spectacular way possible. This Harvard astrophysicist has essentially declared war on the entire scientific establishment by suggesting that a massive object racing toward Earth might be artificial. We're not talking about some fringe researcher making wild claims from his basement. Loeb has published hundreds of peer-reviewed papers, served as department chair at Harvard, and advised NASA on space missions. When someone with these credentials starts questioning whether we're alone in the universe, it sends shock waves through academic circles that are still reverberating today. The object causing all this controversy is called 3I-ATLAS, and it's about the size of Manhattan Island. It will make its closest approach to Earth on December 17th, traveling at roughly 41 meters per second. But here's what's got everyone's attention. This thing doesn't behave like any natural object we've ever seen before, and Loeb isn't afraid to say what everyone else is thinking but won't dare to whisper. The reaction from his colleagues has been swift and brutal. The scientific community has developed what can only be described as an allergic reaction to anyone suggesting that weird objects in space might not have natural explanations. But Loeb keeps pushing forward, armed with data that gets more puzzling every day and a willingness to consider possibilities that make other scientists break out in cold sweats. What makes this situation even more explosive is the timing. We're living through an unprecedented period of government transparency about unidentified phenomena. Intelligence agencies that spent decades denying the existence of anything unusual are now releasing reports acknowledging encounters with objects they can't explain. The convergence of official acknowledgement and the arrival of 3I-ATLAS creates a perfect storm that's forcing everyone to confront questions they've been avoiding for decades. The numbers don't add up. The mathematical problems with 3I-ATLAS start with its absolutely ridiculous size. At roughly 20 kilometers across, this object dwarfs every other interstellar visitor we've detected. The previous objects we found, like 1 Yuma and 2I Borisov, were hundreds of times smaller. It's like collecting pebbles on a beach for years and then suddenly stumbling across a boulder the size of a city block. Astronomers have calculated that we should only see a rock this size maybe once every 10,000 years or longer. Yet here we are, barely a decade into systematic sky surveys, and we found something enormous. The probability calculations become even more bizarre when you consider that we've detected 3 interstellar objects in rapid succession, with the third being dramatically larger than the first 2. But the size issue is just the beginning of what makes this object mathematically impossible to explain naturally. The trajectory of 3I-ATLAS looks almost too perfect to be accidental. It's aligned within 5 degrees of the plane where all our planets orbit around the Sun, giving it approximately a 1 in 500 chance of occurring randomly. That's already suspicious, but it gets much weirder. When researchers factor in the specific timing of its arrival and the route it's taking past multiple planets, the probability calculations become absolutely insane. This object will come close to Mars, Venus, and Jupiter during its journey through our solar system. The odds of this happening purely by chance are roughly 1 in 20,000. It's almost as if someone designed the perfect sightseeing tour of our solar system's greatest hits. Even stranger, 3I-ATLAS is traveling in what's called a retrograde orbit, meaning it's moving in the opposite direction from how our planets circle the Sun. This type of path would be ideal if you wanted to release smaller probes or conduct detailed observations of multiple worlds. It gives you more time near each planet and better viewing angles for comprehensive study. The speed calculations create additional headaches for conventional explanations. At 41 meters per second, this object is moving twice as fast as the fastest rockets humans have ever launched and significantly faster than previous interstellar visitors. While this speed could theoretically result from natural processes, it falls within a narrow range that seems almost calibrated for detection by civilizations with our level of technological development. The image that changed everything. The Hubble Space Telescope captured high-resolution images of 3I-ATLAS that completely shattered expectations about how this object should behave. Instead of showing the characteristic tail that every comet develops as it approaches the Sun, the images revealed something that doesn't match any known natural process. What Hubble photographed was a strange glow surrounding the object, but not in the way anyone expected. Normal comets develop tails that stream away from the sun as solar wind and radiation pressure push ejected material into space. These tails always point away from our star, creating the beautiful streaming patterns that make comets such spectacular sights. But 3I-ATLAS is doing something completely different. The glow around this object actually appears in front of it, heading toward the sun rather than being pushed away from it. This is the complete opposite of how normal comets behave, and nobody has a convincing explanation for what could cause such a phenomenon. The absence of typical cometary behavior becomes even more significant when you consider that 3I-ATLAS should be warming up as it approaches the sun. Any ice or frozen materials on its surface should be sublimating and creating visible outgassing that would produce the expected tail. The fact that this isn't happening in the predicted way suggests that this object might be made of something entirely different from normal space debris. NASA has officially classified 3I-ATLAS as a comet and stated that it poses no threat to Earth, maintaining that it will stay at least 150 million miles away. But NASA's track record on object identification isn't exactly perfect. They once embarrassingly mistook Elon Musk's Tesla Roadster for a new asteroid after SpaceX launched it into space. The Hubble images have forced scientists to confront the possibility that their assumptions about what constitutes normal behavior for space objects might be fundamentally wrong. If 3I-ATLAS isn't following the rules that govern comets and asteroids, then what rules is it following? And who or what might have written those rules? Academic war zone. The scientific community's reaction to Loeb's suggestions about 3I-ATLAS has exposed deep fractures within academic culture that go far beyond disagreements about data interpretation. What's happening isn't just professional skepticism. It's a full-scale assault on anyone brave enough to consider possibilities that don't fit established paradigms. Loeb created something called the Loeb scale to help evaluate objects like 3I-ATLAS, ranking them from 0 for purely natural to 10 for definitely technological. He currently places 3I-ATLAS at a 4, meaning it shows characteristics that could indicate artificial origin. This middle ground assessment drives other scientists crazy because it forces them to acknowledge uncertainty rather than retreating into comfortable conventional explanations. The resistance he faces reveals how academic institutions actually operate behind the scenes. Universities have evolved into echo chambers that reinforce existing beliefs rather than challenging them. Researchers who propose radical ideas often find themselves marginalized, denied funding, and excluded from prestigious conferences. The current reward system actively punishes the kind of intellectual risk-taking that leads to major breakthroughs. The politicization of academia has made these problems even worse by introducing ideological considerations into what should be purely empirical investigations. When universities align themselves with particular political perspectives, researchers face pressure to produce conclusions that support preferred narratives rather than following evidence wherever it leads. The contrast with earlier periods of scientific discovery is absolutely striking. During the golden age of quantum mechanics, researchers like Niels Bohr were making revolutionary discoveries at a rate that far exceeds anything we see today. Despite having far fewer resources and much simpler technology, the difference wasn't talent or tools. It was a culture that welcomed radical possibilities. Today's academic culture prioritizes consensus over discovery, safety over innovation, and institutional approval over intellectual honesty. Researchers learn early that proposing ideas outside the mainstream can destroy their career prospects. The result is a scientific community that's become risk-averse exactly when it should be most open to paradigm-shifting discoveries. The economic apocalypse. If 3I-ATLAS proves to be artificial, the economic implications could make every previous financial crisis look like a minor market hiccup. Loeb has suggested that stock markets might crash upon confirmed discovery of alien technology, but that represents just the opening act of an economic transformation that could reshape human civilization. The technology sector would face immediate chaos as investors scramble to figure out which companies might benefit from access to superior alien technologies and which ones might become obsolete overnight. Defense contractors could see massive value increases as governments desperately try to understand potential threats, while entire industries might face complete collapse if extraterrestrial visitors possess capabilities that make human technology look primitive. Energy markets could experience the most dramatic disruption of all. If alien civilizations possess advanced propulsion systems or revolutionary energy generation technologies, entire industries based on fossil fuels, nuclear power, and current renewable sources could become worthless within months. The global energy economy worth trillions of dollars annually might require complete reconstruction from the ground up. Financial institutions would face unprecedented challenges as risk models developed for terrestrial scenarios become completely inadequate for situations involving technologically superior extraterrestrial intelligence. How do you calculate insurance premiums for alien contact scenarios? What coverage should banks provide for technology disruption caused by beings who've been developing for millions of years longer than humans? International trade agreements and economic partnerships could collapse as nations reassess their strategic priorities in light of contact with civilizations possessing interstellar travel capabilities. Current economic competition between countries might seem absolutely trivial compared to the challenge of establishing relationships with visitors who can cross the galaxy. The global workforce would confront massive displacement as entire industries become obsolete while completely new sectors emerge around extraterrestrial-related technologies and communications. Education systems would need immediate reconstruction to prepare people for careers in fields that don't currently exist but might become essential for human survival and prosperity. We are running out of time. As 3I-ATLAS races toward its closest approach to the Sun, scientists are facing a rapidly shrinking window to determine its true nature before observation opportunities disappear entirely. The object's incredible speed means researchers have limited time to collect the data they desperately need to solve this cosmic mystery. The real moment of truth will come over the next few months as solar heating should force 3I-ATLAS to reveal whether it behaves like a normal comet or something entirely unprecedented. If it's made of ice and rock like typical space debris, it should start erupting and outgassing as it gets closer to the Sun, creating the beautiful tail that everyone expects to see. But if it's something else entirely, we might observe behavior that doesn't match anything in human experience. The heating process should reveal crucial information about the object's composition and structure, potentially answering questions that could determine humanity's place in the universe. Unfortunately, the timing creates observation challenges that seem almost designed to limit our ability to get clear answers during the most critical period. On October 29, 2025, when 3I-ATLAS reaches its closest point to the Sun, Earth will be positioned on the opposite side of our star. This means our best ground-based telescopes will struggle to get observations exactly when solar heating should reveal the object's true nature. The mathematical precision of this timing coincidence pushes probability calculations toward levels that challenge purely accidental explanations. Objects following random trajectories through space shouldn't show such perfect coordination between arrival timing and Earth's orbital position. It's almost as if 3I-ATLAS is trying to avoid direct scrutiny during its most revealing moment. Scientists aren't giving up without a fight. Space-based telescopes like Hubble and the James Webb Space Telescope should still be able to track the object even when ground-based observations become impossible. These instruments have already provided valuable data about its unusual characteristics and will continue monitoring as heating from the Sun forces any hidden properties to become visible. One of the most important things researchers will be watching for is any sign of non-gravitational acceleration. If 3I-ATLAS changes course or speed in ways that can't be explained by gravitational attraction from planets and the Sun, that would constitute definitive proof of artificial propulsion. So far, no such deviations have been reported, but measurement precision should improve dramatically as the object gets closer and brighter. Countdown to glory or catastrophe. The approach of 3I-ATLAS is forcing humanity to confront fundamental questions about our readiness for what might be the most significant moment in human history. Whether this object proves natural or artificial, it's already revealed dangerous gaps in our preparation, the scenarios that could fundamentally alter civilization as we know it. Loeb believes that by the end of September, we should have definitive answers about the nature of 3I-ATLAS. If it's a comet, it will warm up and erupt in typical fashion as it approaches the Sun. If it's something else entirely, the heating process might reveal characteristics that challenge everything we thought we knew about what's possible in our cosmic neighborhood. The scientist has instructed his research team to pay special attention to the months following the object's closest approach to the Sun. If 3I-ATLAS does release smaller probes or if unusual activity appears in Earth's atmosphere, it might happen during this critical period. The Galileo project's machine learning systems are documenting everything and looking for outliers that might indicate technological activity. The possibility that this object might represent first contact with extraterrestrial intelligence raises uncomfortable questions about whether humanity is prepared for such a discovery. The scientific community's hostile reaction to even suggesting this possibility demonstrates how unprepared academic institutions are for genuinely paradigm-shifting discovery. But ready or not, answers are coming. The laws of physics will force 3I-ATLAS to reveal its true nature as solar heating intensifies over the coming months. Whether it erupts in typical cometary fashion or behaves in ways we've never seen before, the mystery will be solved within weeks. If the object proves artificial, it would represent the most significant event in human history, fundamentally changing our understanding of our place in the universe. If it turns out to be natural after all, it will still have served an important purpose by forcing us to question assumptions and consider possibilities we've previously ignored. The quality of humanity's response to this challenge may determine whether we're ready for what comes next or whether we'll fumble the most important moment in our species' existence because we were too afraid to prepare for realities that challenged our comfortable assumptions about being alone in the cosmos. Let us know your thoughts in the comments down below. Don't forget to like and subscribe for more content on 3I-ATLAS.